In this video, we're going to talk about circle equations. So the general form of the equation of a circle is x minus h squared plus y minus k squared equals to radius squared. The center is the point HK. So h represents the x coordinate of the center of the circle, and k represents the y coordinate of the center of the circle, and r represents the radius of the circle. So we're going to write an equation for the circles below using the given information. So in number 1, they give us the center of the circle and they give us the radius. So when we plug in to the format for the equation of the circle, we have x minus the x coordinate of the center, which is 5, squared, plus y minus the y coordinate of the center, which is 2, squared, is equal to radius squared. So the radius of the circle is given at 7, so 7 squared is what would go here. So notice how when you plug into the format for the equation of the circle, the x and y coordinate of the center look like it's the opposite signs because there's that built-in minus in the format for the equation of the circle. In the next one, we're going to do the same thing. We're given the center and the radius, and we're going to write the equation of the circle. X minus the x coordinate of the center. The x coordinate of the center is -3. So here we have x minus -3. We can also rewrite that as x plus 3 because a minus minus makes a plus. Plus y minus the y coordinate of the center, which is 4, squared, is equal to radius squared. So the radius here is 2 radical 5. You could also simplify that. So over here, we could have also written 49. That's what 10 squared is. Over here, we could write what 2 radical 5 squared is instead. Let's see what that is. 2 radical 5 squared is 2 radical 5 times 2 radical 5. That is 4 times radical 25, which is 4 times 5, which is equal to 20. So we could also write 20 here instead of 2 radical 5 squared, but I'm just going to leave it as 2 radical 5 squared so you could see that the right-hand side of the circle equation is radius squared. It's not just radius, it is the radius squared. Over here, we have an example that's a little bit different. This time, we're given a circle with the endpoints of the diameter. So we don't have the center of the circle here, and we don't have the radius of the circle like we had in the other two examples. We need the center and the radius in order to write the equation of the circle. So we're going to have to figure out how to find the center of the circle and the radius so that we can write the equation. I'm going to do a really quick estimate graph so we can see these points. So the point 5, 1 is somewhere over here, and the point 3, -1 is somewhere over here. So we're told that these are endpoints of the diameter. So what that means is that these are points that are on the circle, and the diameter of the circle passes through the center. So let me fix my drawing a little bit. Give me 1 second. Okay, so it's not a great drawing, but it's an estimate drawing. So the diameter of a circle goes from one point on the circle to another point on the circle. And the important thing about a diameter is that it passes through the center of the circle. So if I want to find that center of the circle, all I have to do is find the midpoint of the diameter, the midpoint of this line segment, because the midpoint will be the middle or the center of this line segment. So my midpoint formula is the average of the x coordinates, comma, the average of the y coordinates. So that would be 8 over 2, comma, 0 over 2, which would be the point 4, comma, 2. So that's the center of the circle. Center of the circle is the point 4, 2. The only other thing we have to find is the radius of the circle. We have two options. We can find the length of the whole way across, the length of the diameter, using the distance formula, and then we can divide it by 2 to get the radius, because radius is half of the diameter. Our other option is we can take one of the endpoints and the center, and we can find the length from that endpoint to the center. And that would be halfway across the circle, which would give us the radius. We wouldn't have to divide anything afterwards. Next option I'm going to do, I'm going to use the distance formula to find the distance between one of the endpoints and the center of the circle. So I'm just going to use the 0.51. It doesn't matter which of the two endpoints you use, but if I don't have to use negative numbers, I don't want to. So let me plug into my distance formula. My distance formula is x2, so I'll use 5 for x2, minus x1, y2, minus y1. That would be 1 squared plus negative 1 squared. We have 1 plus 1, and that's equal to radical 2. So that's our radius. That's our halfway across from one of the endpoints to the center of the circle. So now that we have our center and our radius, we can write the equation of the circle. The equation is x minus the x coordinate of the center, which is 4, squared, plus y minus the y coordinate of the center of the circle, which is 2, squared, equals to radius squared. Radical 2 squared is just 2. A radical times itself is just the number underneath the radical. So you can also just write this as 2. So I'm going to rewrite this simpler. Radical 2 squared is just 2. If you take a look at this equation of the circle that we have over here, we have an equation of the circle, but it doesn't look like the format that we had before. I don't see the x minus h squared or the y minus k squared or the radius squared. So when we're looking at an equation like this, we don't really have a lot of information about the circle because we can't tell what the center and the radius is just from looking at the equation. So what we have to do is we have to put it back into our standard form, the way that we're used to seeing the equations of the circle so that we can clearly identify the center and the radius. The way that we're going to do that is by completing the square. Before we complete the square, we're going to have to rearrange this equation because right now we have a lot of terms with x and terms with y that are just mixed up with each other. So the first thing that we're going to do is we're going to group the x terms together and we're going to group the y terms together. So first I'm going to group the x terms. So I have x squared and 16x, a positive 16x. And I'm just going to put a box here because we are going to be completing the square. So I just want to set that up. Plus our y terms are y squared and negative 22y. And once again, I'm just going to put a box because I'm going to be completing the square. And that's equal to, we want to take the constant and move it over to the other side. And when we take the constant and move it to the other side, it's going to change from negative 20. We're going to add it to both sides. So it's going to become positive 20. And since we have an equation here, we do have to keep our equation balanced. So if we're adding these two things that we don't know yet that we're going to find, but if we're adding these two things to the left side of the equation, we're also going to have to add them to the right side of the equation to keep our equation balanced. So I'm just going to make the same two boxes over here. Just to remind myself that whatever I add here and here, I also have to add to the other side to keep my equation balanced. So move the constant and leave 2 spaces. Now, to find the term that completes the square, we call that the C term, A, B, C, A, B, C. So to find that C term that completes the square, that constant that completes the square, we have a formula that we use, and that is that C is equal to B over 2 squared. So this is our A term. Our B coefficient here would be the 16. This is our A term. Our B coefficient here would be negative 22. Let's complete the square for the x terms first. So I'm just going to keep using green for the x terms. So when I plug in, I have 16 over 2 squared. That's 8 squared. So that gives us 64. So 64 is the number that completes the square. If I add it to the side, I'm also going to add it to the side to keep our equation balanced. So the 64, not the 69. Let me make that a little bit more clear. That is a 64. There we go. That's a little bit neater. Okay. Now, we need to get this a little bit simpler over here because it's still not looking in the correct format. So we're actually going to factor this trinomial. And since we completed the square, there's a really easy trick for factoring this. You could factor it the regular way, two numbers that multiply to give you 64 and add to give you 16. But the easier way is since we completed the square, this is going to factor to the same factor repeated twice. And it's going to factor to the b over 2 before we squared it. So our b over 2 before we squared it was 16 over 2, which is 8. So positive 8 is the number here that this trinomial will factor to. Okay, let's complete the square for the y terms, and then we'll factor that one as well. I'll do that up here. So our b term for our b coefficient for the y terms is negative 22. If we divide that by 2, we get negative 11 squared, and negative 11 squared is 121. So 121 is the number that completes the square for the b terms. And remember that really easy trick of factoring? It's going to factor to whatever the b over 2 was before you squared it. So that was negative 22 over 2, which is negative 11. And now all we have to do is add the constants on the right side of the equation. So if I get my calculator and I do 20 plus 64 plus 121, I get 205. So now if we need to identify the center and the radius, it's much easier because now we have our equation in the correct format. I see that my center is negative 8 because remember in our original equation of a circle, it's x minus h squared. So if I'm seeing a plus here, it's because there was a minus originally to make minus minus, which turns into a plus. So it's always opposite signs from what you see in the circle equation. So that would be negative 8, positive 11. And remember, this is radius squared. That's not the radius on the right side of the circle equation. So to get the radius, we do have to take the square root. So our radius would be radical 205. And now we're finished. We changed the format of this equation into our regular format that we could see the center and the radius of. And then we identified the center and the radius from the equation. Let's do one more. This one is a little bit different because when I start grouping the x and the y terms together, I realize I only have one x term. There was supposed to be another one. So I'm going to put a 0x because it's not there, but it was supposed to be there. And 0 times anything is 0, so it's not really there. Plus the box. Grouping my y terms together, same thing with the y's. There is no second y term, so I'm going to put a 0y. And then when we move the 8 over to the other side, that's a positive 8. And I'm going to just make my 2 boxes because I am going to be completing the square. Now, we can't complete the square if the leading coefficient is greater than 1. And here the leading coefficient is 2. So actually, we're going to have to divide everything, this whole equation, by 2 before we get started. 2 divided by 2 is just 1. So we have 1x squared. 0 divided by 2 is 0. That didn't change. 2 divided by 2 is 1. So that's y squared. 0 divided by 2 is 0, so that's 0y. 8 divided by 2 is 4. And then our two numbers that are going to complete the square. So when we're plugging into our b over 2 squared to find our c term, our b coefficient is the same for both of these. So it's going to be the same thing. And it's 0 over 2 squared. Well, 0 divided by 2 is 0. And 0 squared is just 0. Because 0 times 0 is 0. So 0 is the number that completes the square. So when we factor here, everything repeated twice, that's just going to be 0. And I'm just going to put minus 0 in the equation of a circle, it's x minus the x-coordinate. 0 doesn't have a sign. It's not positive or negative. So just to make it look like the equation of the circle, I put a minus 0. And y is going to factor to the same thing. So now we can clearly see the center of our circle, 0.00, the origin, and our radius. Remember, this is r squared, so it's radical 4, which is 2. So if I'm graphing this, I can graph my center of my circle at 0, 0. The radius is 2, so I can graph 2 units out. And if I don't have a compass, I can't get it really circular, but I can do my best to make it as circular as possible. All the points on the circle should be 2 units from the center because the radius is 2. One more for today's video. A circle has a center at 1, -2, and a radius of 4. Does the point 3.4, comma 1.2 lie on the circle? Well, first, since I have the center and the radius, I'm going to write the equation of the circle. That would be x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center squared equals to the radius squared. I'm just going to rewrite this so it's a little bit easier to look at because minus minus makes plus, and 4 squared is 16. So now if I want to see if this point is on the circle, this is the x-coordinate of my point, that's the y-coordinate of my point, I can just plug it in and see if I get a true statement. So that would be 3.4 minus 1 squared plus 1.2 plus 2 squared is equal to 16. I'm going to type this into my calculator. Parentheses, 3.4 minus 1, close parentheses squared, plus parentheses, 1.2 plus 2, close parentheses squared. So I'm going to type this whole left-hand side into my calculator and hit enter, and I get 16. 16 is equal to 16. That is a true statement. So yes, this point does lie on the circle, and our work here justifies it. When we take our equation and we plug the point into the equation of the circle, we get a true statement. So the point does lie on the circle. The answer is